Hello, welcome back. Today we will talk about the IP address. So, what is IP address? What is the format of the IP address? Why IP address is needed in networking, and how we convert an IP address from decimal to the binary and binary to decimal. And then finally, we will see a very short lab so that we can see how we configure the IP address, and just to get an idea like what IP address I have or we have in our laptops. Okay, so let's start. So IP address is an internet protocol address. Again, IP address is an address for internet protocol. An IP address is a logical address. That means we can change the IP address of a laptop or of a computer or of a device based on the network or the IP address you are designed for your network. And this IP address is worked on the network layer. So in my another video, I discuss about the layered architecture of networking. So if you can look at that, so you will get a clear idea about the layering of the TCP/IP model or reference model. So please have a look on that video to get a better idea about the layered architecture or the different layer of networking. So IP address work in the layer 3 or the network layer or the internet layer. So the name of the layer 3 we call it a network layer or the internet layer. So IP address is used to find a device in the network to communicate each other. That means like you are in one place and you are connected, your friend is connected to other end of the planet, and you want to communicate to your friend, you want to send a message to your friend, and which is connected to the internet. So that means both of you, your laptop and your friend laptop, must have an IP address so that they can find each other and then communicate to each other. For example, in this case, in this simple topology, you can see you have some we have some computers and we have some network devices like switches and routers, and they are connected to each other. So that if PC1 want to communicate to PC2, so PC1 need to know the IP address of the PC2. In the same way, if PC2 want to communicate to the PC11, so PC2 need to know the IP address of the PC11. So again, IP address is a logical address. Why logical address? Because it is not a hard-coded address of a device. You assign the IP address to your device based on your IP address design for your enterprise networks, and it works in the internet protocol. That means it is in the layer 3 or the network layer. And the key purpose of the IP address is to find a device in the networks that is connected to the internet or connected to the network so that they can communicate each other. So IP address has the two different versions. So version 1 is IP version 4, and then the another version is called IP version 6. So IP version 6 is came later. So first the previous version of the IP is the IP version 4, and because gradually we need more devices, so we need more IP addresses connected to the internet or connected to the networks, so we need more number of IP addresses, and this is why actually the newer version or IPv6 came into the picture. So today in this tutorial we will talk only about the IPv4. You might see the another video. I will discuss about IPv6 later. So IPv4 is represented as a dotted decimal number. Dotted decimal number. Why dotted decimal number? Because the way IPv4 address is represented, use the decimal number, like 192 is a decimal number, 10 is a decimal number, and they are separated by dot. So that's why it's called the dotted decimal number. And each of the decimal number is in the binary representation of 8 bits. So we have 4 8 bits, so together 32 bits. So that's why IPv4 address is 32 bits. So each of the decimal number separated by dot is represented by 8 bits binary value. So 8 times 4 is 32. So now let's see more details on how the IPv4 address works. For example, in this case, if we set the first byte, then another byte, then another byte, then another 4 byte, or sometimes we call it octet. So the 4 octet. So each octet could have all the 8 bits are 0 or all the 8 bits are 1. So that means from all the 8 bits 0 to all the 8 bits is 1. So we can represent the each of the octet from 0 to 255 decimal number. So highest decimal number we can have in the IPv4 address in one octet is 255. So it could be any number in between 0 to 255. So the range of IPv4 address, so all the 4 bytes or 4 octets could be 0 to all the 4 octets are 255. So 255, 255, 255, 255. So total number of IPv4 address we can have is 2 to the power 32, so which is about 4.3 billion devices or 3 billion IP addresses. But now day by day more devices are connected to the internet, more devices are connected to the network due to new technology like IoT and other inventions. So we need newer version of the IPv4, which is IPv6, and we will discuss that later in another video. So here is another example IPv4 address. So for example, we have one IPv4 address 192.168.10.10, which is 32-bit address. So this is called the dotted decimal address, and corresponding binary value of this 192.168.10.1 is the 32-bit binary address, like 11000000. Then 168 is 10101000, right? So same way all the decimal value can be represented as a binary value, and we will get the 32-bit binary address. So each of these are again called as an octet. So let's see how we can convert an IP address from decimal to binary and binary to decimal quickly. Okay, so our focus is basically on the IP address. So we'll see how we can convert an IP address quickly from binary to decimal and decimal to binary. So for example, in this case, we have an IP address which binary format is 10110000. So to convert it to the decimal value, so let's consider so if it is the binary, so the base of binary is 2. So we can represent the bit value based on the base value of the binary. So 2 to the power 0, 2 to the power 1 until 2 to the power 7. So 2 to the power 0 is 1, and 2 to the power 1 is 2, 2 to the power 2 is 4, and respectively 2 to the power 7 is 128. So now if we want to convert this binary to the decimal, that means binary is 10110000, 10110000. What we need to do, we just need to add the decimal value corresponding binary value of 1. So we have 1, so corresponding value is 128. We have another one, corresponding binary value, decimal value is 32. And we have another one, and the corresponding decimal value is 16. So if we add all these three decimal value, we will get 176. So the binary conversion of this 10110000 is actually, binary to decimal conversion is actually 176. So here is another example, like if you have all the 8-bit are 1, so what we need to do, we need to add all the decimal value to convert this binary to the decimal. So if we add all these decimal value, then we will get 255, right? So in the previous slide I said, so 0 0, all the 0 to all the 1, that means 0 to 255. So this is all our 1 binary value, so we got the corresponding decimal value is 255. So now if you look at here, so we have the octet, so binary value of all the 4 octets, that means of a IP address of a binary format. And if we want to convert this to a decimal value, so here is all the bit value, right? So that means in case of octet 1, we have first 2 bit are 1, so we are adding only the corresponding bit value or bit decimal value of first 2, so which is 128 plus 64, which is 192. In the same way, in the octet 2, we have first or the 7th bit is 1, then the 5th bit is 1, and the 7th bit 1, 5th bit 1, and the 3rd bit 1. So we are adding all those, the corresponding bit value, like 128, then 32, and then the 8. So we are getting 168. Similarly, so for 1010, that means the first bit is 1 and the 4th bit is 1, so the 2 and the 8 10 and then 10. So now if we write it in a dotted decimal value, 192.168.10.10, so the binary IP address is now converted to the decimal IP address. So now we see how we can convert, or we know how we can convert a binary IP address to a decimal IP address. So now let's see how we convert from decimal to binary, right? So consider 192.168.10.10. This is our decimal value of an IP address. We are trying to convert 168 to a binary, right? And this is our bit value. So how can we convert the decimal to the binary? It's very simple. Like for example, we want to convert again 168 to the binary. So we will compare 168 to the 7th bit or the most significant bit. So we will see 168 is bigger than or equal to 168. So if it is bigger than and equal, we will replace the 7th bit of the binary value to 1. So now 7 bit is 1. Okay, or you can say, the reason I am saying 7, I am considering here is 0. So 0 1 2 3 4 5 6 7, so altogether 8 bit. Okay, so now we need to find the difference between 168 and 128. So the difference between 168 and 128 is 40. Now again we are comparing 40 is greater than or equal to the next bit value, so which is 64. So the 40 is not greater than or equal to 64. So we will say our 6th bit is 0. So now again we are comparing the next bit value, so the 32 with 40. So 40 is greater than or equal 0 or not. So 40 is greater than yes, so we will replace the value of the 32 or the fifth binary bit is 1. And then we need to again find the difference between the 40 and 32. So 40 and 32 is 8. So now again we are comparing 8 is bigger than or equal to the next bit value, which is 16. So it is not bigger than or equal, so the no. So then we are using the 0 or replacing the 0 in that bit value or the binary value. And then we are looking for the next decimal bit value, so which is 8. So 8 is greater than or 8 is equal to 8. So we are replacing the binary value of that bit is 1 and the remaining are 0. So that means the binary value of the decimal 168 is 10101000. So you can convert a decimal value to binary with this simple process. Okay. Now let's see the full conversion of 192.168.10.10, right? So 192.168.10.10. So 192 is 1100, then the 168, then 10, and then 10. So now you are getting your decimal to the binary value, so which is the binary value. So this is how we can convert a decimal IP address to the binary value of the corresponding IP address. Okay, so let's see. Actually, the lab means this is not that kind of lab. That's just I want to show you like where actually you can find the IP address of your device, right? So for example, if I want to see the IP address of my device, or you want to see the IP address of your device, you can go to the command prompt of your computer. So if you open your command prompt in your laptop and write ipconfig, ipconfig together, and then one space, then /all. So if you write that, you can see something like this, and then you can see the IP address. For example, wireless LAN adapter Wi-Fi connection in your laptop, and you have the IP address here. So IPv4 address 10.0.0.156. Or if you look at the Ethernet connections, so another network connection, so you can see IP address something 192.168.137.1, right? So something like we discussed. So you can find that means every laptop or every computer need an IP address. So let's see another example in the packet tracer. For example, we are connecting one PC here and one laptop, and you are connecting both of them by using crossover cable, so Ethernet 0, and here is Ethernet 0. And to communicate to them, so we need to configure the IP address. So configuring IP address, so for example 192.168.10.1, right? So I give an IP address of this PC1, and then I am again allocating or assigning the IP address of the laptop, IP address of laptop 1. So 192.168.10.2. So I give another IP address to this laptop. So now they can communicate with each other by using this IP address. Let's see, can we communicate? Can the PC1 can communicate to the laptop 1? So the IP address of laptop 1 is 192.168.10.2. So let's try to ping the laptop 1, ping 192.168.10.2. Right? So that means ping is a very common and very useful and mostly used command to test a network from one to end or end to end reachability. Right? So that means when the PC1 pinging to laptop 1 and laptop 1 then reply back. So it says the reply from 192.168.10.2. So 10.2 is laptop and it's replying back to the PC1. So if you look at again, if you see the same thing from here, so we need to ping from 192.168.10.1 because 1 is the IP address of the PC1. So now if we enter, that means you can see now the reply from the PC1, which this 192.168.10.1 is the IP address of PC1. So IP address is, we actually see how we can find that. That means every laptop, every device in a network need an IP address, and we need to configure the IP address to the devices, but there are some other way to configure the IP address automatically. We'll see that, we'll learn that later any other video. So thank you very much for watching the video. I hope this video will help to you to understand the basic of IP addressing and how we can convert from binary to the decimal and decimal to binary of the IP addresses. And the next video I will talk about more on the different type of IP addresses or more details on specifically the format of IP addresses, different class of IP addresses. Okay, more design perspective of the IP addresses. So thank you very much.